To look at a relationship between variables, we want to look at a picture or a graph. And a graph is just going to be a picture of all what we're going to call solutions. Now solutions, we're going to come in an ordered pair that looks like an x and a y. And this is going to be in some sort of relationship. So let's just look at what would an x comma y ordered pair look like. Well, we might have one that looks like 3 comma 2. Notice 3 is in the x position. So looking at our coordinate system, we need to know who is x and who is y. So on a coordinate system, we have these axes, we call them, and they look kind of like crosshairs in a scope. This right here is called the origin. We call this the x-axis and this the y-axis. And what they are just two number lines that are intersecting vertically and horizontally. So if we look on this side, these are going to be negative values. On the right, positive values. Going up would be positive, and going down would be negative. So again, they're just two number lines that are intersecting. So if I want to look at the relationship 3 comma 2 in a coordinate system or on a graph, what I need to do is go in the x direction, positive 3. So on my x-axis, I went over 3. And in my y-axis, go up 2 from that point. So my origin 0, 0 is where I always start, and then I move right 3 and up 2. Let's try to graph another ordered pair. Maybe I've got negative 2, 0. So the negative 2 is in the x position, which says go to the left 2. And the 0 says don't go up or down any. So that's where that spot would be located. If you take a look at this, when you have a 0 in any one position, it means you're going to be on the axes. So this case says go up 4, go right 4, and up 0. This is the x, this is the y. If I wanted to go up 4, it would have been 0, 4. 0 in the x and 4 in the y. So if we notice this coordinate system, everything in what we call quadrant 1, which is this region, has a positive x value and a positive y value. In the second quadrant, which is this green area, we're going to label it the second quadrant. In this area, x's are negative, y's are positive. In the third region, or quadrant, quarter, in this case, x is negative and y is negative. And in the last region, x is positive and y is negative. So that kind of tells you where you're going to be situated when you plot those ordered pairs. How are we going to get those ordered pairs and a graph? Well, they're going to come from an equation. An equation is just a relationship mathematical and that relationship is between two variables. And what this relationship does, that is between two variables, it's going to be a model. And it's going to model real world. That's oftentimes why we want an equation in a given situation. So if I have this equation, I might be looking for a solution. And a solution is going to be that ordered pair. And what's it going to do? Well, to be a solution, it's got to make the equation true. And when we say true, what we mean by that, it's got to uphold that equal sign. For example, here's an equation, 2x plus 3y equals 12. Notice we call an equation because it's got that equal sign. It's not an expression, it is an equation. So there's my equation, and I want some ordered pairs that make that equation true. I want to find solutions. Is 0, 4 a solution? Well, how do I tell? X is 0, y is 4. My equation, my equal sign, is true. Algebra is about left hand equaling right hand. My left hand, 3 times 4, is equal to my right hand. Does 6, 0 make that equation true? Is 2 times 6 plus 3 times 0 also equal to 12? Yes, it is. Left hand equals right hand. Is 3, 2 a solution? Well, the only way to tell is to plug in the x coordinate of 3, plug in the y coordinate of 2, and see if it's equal to 12. So the x coordinate of 3 should be 2 times the x, so we better fix this error. 2 times the x plus 3 times the y. And checking this out by multiplying, yes, left hand equals right hand. Would the ordered pair 1, 4 be a solution? Would the ordered pair 1, 4 be a solution? Well, again, the only way to check is says take 2 times the x coordinate, add to that 3 times the y coordinate, and does that equal to 12? Well, 2 plus 12 does not equal to 12, so no, it is not a solution. So again, in order to tell if you have a solution to one of these relationships, you plug in the x for x and the y value for the y, and just see if the equal sign is made true, if it upholds. Now, when we take these points and plot them, we've made a scatter plot. Scatter means it's just dots everywhere. So we're going to take these 3 points, which were solutions, and we're going to plot them. So the first one says x is 0, y is 4. So that just means I'm going to head up, and I'm actually going to land on my y-axis. The next solution was 6, 0, which lands me on my x-axis. And the last point was x is 3, y is 2. So I went to 3 and 2. Okay, and those are just directions there. It's kind of like the game of Battleship. But look, that's a scatter plot. I see dots that are my solutions. Are those the only solutions? No, there's actually infinitely many solutions. So when we look at a graph of an equation, we're not looking at just individual solutions that I found. We're going to get a picture of all solutions. And so that means whether they be a decimal, very, very small, etc. So when I graph a picture of all solutions, if this is my x and y coordinate system, I would again be plotting those original ones that we found as solutions, the 0, 4, the 3, 2, and the 6, 0. Now what I do for a graph is I connect them all. It's continuous, because every point on this line would be a solution to my equation, y equals 2, this 2x plus 3y equals 12. I could find decimal values that make that true. And so that's the difference between a graph, it's continuous, and a scatter plot with just certain particular values that most likely were easy to find were plotted. Those values come from this idea of being a solution, a correct answer to my equation.